We're going to go ahead and go over the 7.3 worksheet number 2, which is where you practiced identifying independent and dependent events and then finding the probability. For number 8 and 9, we are using the directions that a bag contains 20 checkers, 10 red and 10 black. Determine whether the events are independent or dependent and then find the indicated probability. So number 8 says selecting 2 black checkers when they are chosen at random with replacement. So that means we pick out a checker, we put it back, and we pick out another one. So I want the probability for number 8 of doing, pulling a black checker and then doing it again. Well, there are 10 black checkers out of a total of 10 plus 10, which is 20 checkers. So 10 out of 20. And I'm going to multiply that by the probability of pulling out a second one, given that I've replaced it. I've pulled one out and I've put it back. So we still contain 20 checkers in that bag, and there are, once again, 10 in there. I see this as really being 1/2 times 1/2, so I would simplify and then multiply to get 1/4 as my answer. Number 9, selecting 2 black checkers when they are chosen at random without replacement. So same directions. It's probability of pulling out a black times probability that the second is a black, but we put it, we did not put it back. So there were 10 out of 20. But now I've taken a black checker and pulled it out. I no longer have 20 checkers in the bag. I now have 19. Also, I'm pulling out a second black checker. So I've already pulled one out. So there are no longer 10 black checkers in the bag. There are 9. Multiply across the top, across the bottom, or you could simplify. I saw this as being 1/2 times 9 over 19. And then I multiplied to get 9 over 38, which does not simplify. Number 17 and 18 say that we have a bag that contains number slips numbered 1 through 9. Determine whether the events are independent or dependent and find the indicated probability. So if I have slips that are numbered 1 through 9, that means I have 9 different number slips in this bag. 17 says we're selecting 2 even numbers when the slips are chosen without replacement. So without replacement is dependent. Again, I have the slips 1, 2, 3, 4, 5, 6, 7, 8, 9 in a bag. So for number 17, if I want probability of an even and pulling out a second even, there are 1, 2, 3, 4 numbers out of 9 that are even. Because I didn't replace it, I still pulled out an even and I kept it. I now only have 3 evens out of 8 slips. So then you should multiply across the top, across the bottom, and then simplify. So that would have been 12 over 72, which became 1/6. 18. Selecting 2 even numbers with 2 slips are chosen with replacement. So we pull it out, we put it back. That would be independent. So probability of even times probability of even would be 4/9 times 4/9. Multiply across the top, across the bottom, you get 16 over 81, and I believe that does not simplify. 19 through 22, remember, we're not solving, we're just saying, hey, that's independent, or hey, that's dependent. Number 19 says, a coin comes up heads, and a number cube rolled at the same time comes up 6. So we have 2 different things. We're tossing a coin, and we're rolling a number cube. One does not impact the other. So number 19 is independent. All right, number 20. A 4 is drawn from a deck of cards, set aside, and then an ace is drawn. So the key word here is that it's been set aside. So we've taken out a card from the deck, we've kept it, and we're pulling out another one. So now instead of having 52 cards, we're going to be pulling from 51 cards. That means pulling out the first card has impacted the second. So that would be dependent. Number 21 says a 1 is rolled on a number cube and then a 4 is rolled on the same number cube. So we have a number cube, we roll it, then we pick it back up, and we roll it again. These are two separate actions. So that would be independent. It's not saying, hey, we've rolled a number cube on one die, we want it to have this, and we've rolled this on the second die, and we want the sum to be, I don't know, 3. It does not impact it. They're two separate events. I don't have certain criteria, so it's not dependent. Number 22. A dart hits the bullseye, and a second dart also hits the bullseye. So we're throwing two separate darts. These are two separate actions. That's independent. Number 11. A bag contains 25 checkers. 15 red, 10 black. Determine whether the events a red checker is selected, not replaced, and then a black checker is selected are independent or dependent, and find the probability. Not replaced was the key word. Because it's not replaced, that's dependent. So I want the probability of pulling a red, and I want the probability of the second being a black. So there were 15 red out of 25 checkers. Now I've pulled out that red checker and I'm keeping it. So I no longer have 25 checkers in the bag, I have 24. The red checker that I've pulled out does not impact the number of black checkers I have. So I still have 10 black checkers. I didn't pull that out. You could either simplify and then multiply, or you can just multiply across the top and simplify. That's up to you, but we all should have ended up with 150.